Monte Carlo simulation is a computational technique used to model the probability of different outcomes in a process that cannot be easily predicted due to the presence of uncertainty or variability. This method relies on repeated random sampling of inputs to calculate statistical probabilities of various outcomes and perform sensitivity analysis. It got its name from the famous gambling location in Monaco because the method shares the same random characteristic as a roulette game. In the context of project management, Monte Carlo simulation is often used to assess the impact of uncertainty on schedule, cost, risk, and other key parameters. Monte Carlo-based predictions of failure, cost overruns, and schedule overruns are routinely better than human intuition or alternative soft methods. Let's delve into the steps required for Monte Carlo simulation in the context of project management. Firstly, identify uncertainties. Before using Monte Carlo simulation, project managers identify the key uncertainties or variables that can affect the project's outcomes. These variables could include task durations, resource availability, costs, and other factors that may vary. Next step is to define probability distributions. For each identified variable, probability distributions are assigned to represent the range of possible values and their likelihood. Common distributions include the normal distribution, triangular distribution, and beta distribution. Now create a model. A mathematical model of the project is constructed, incorporating the identified variables and their probability distributions. The model may include task dependencies, resource constraints, and other relevant project elements. Next step is to run simulations. The Monte Carlo simulation involves running a large number of iterations, also known as simulations, for the model by randomly sampling values from the specified probability distributions for each variable. These simulations generate a range of possible project outcomes. Fifth step is to analyze results. The results of the simulations provide a probabilistic distribution of potential project outcomes, such as project duration, cost, or resource utilization. This information is often presented in the form of probability density functions or cumulative distribution functions. Next step is involved with extracting key metrics. From the simulation results, project managers can extract key metrics such as the most likely completion date, the probability of finishing the project by a certain date, and the range of potential costs. This information helps in making informed decisions and managing expectations. Finally, risk mitigation and decision-making. Armed with insights from the Monte Carlo simulation, project managers can identify high-risk areas and develop mitigation strategies. The simulation results also assist in making more informed decisions, setting realistic project goals, and establishing contingency plans. Let us understand the Monte Carlo simulation with a sample use case. Consider a use case to analyze the probability of completing a project within a certain time period. Let us assume the project has 3 tasks as shown here. The 3 types of estimation: pessimistic, most likely, and optimistic estimates for the same task to account for risks. For additional analysis, we will calculate the estimation based on PERT technique. From the above calculation, we can deduce that according to the PERT estimate, all of these activities can be estimated to complete in 17.5 months. However, in the optimistic case, it will be finished in 16 months, and in the pessimistic case, it will be completed in 21 months. Now, using the Monte Carlo simulation, let us rerun the model with random values for each task for 500 or 1000 iterations. When the simulation is complete, we can look at statistics from the simulated output. From the above result, we can see that there is a 2% chance of completing the project in 16 months, 8% chance of completing the project in 17 months, 55% chance of completing the project in 18 months, 70% chance of completing the project in 19 months, 95% chance of completing the project in 20 months, 100% chance of completing the project in 21 months. Let us now look at the final comparison of the 3 methods for a simple analysis. For the time required to complete the project, best possible estimate was around 17 months. PERT analysis estimate was 17.5 months, and the Monte Carlo simulation estimate was around 21 months. The benefits of Monte Carlo simulation can be summarized as objective and insightful data for decision-making. Enables project managers to create a more accurate and practical schedule and cost management plan. Accuracy in forecasting schedules and costs. Quantitative risk assessment. Let us summarize the limitations. The outcome depends on the initial inputs provided. It results in probability, not the actual values. It can be time-consuming if the data is huge. It can be computationally intensive, dealing with complex data and many iterations. To conclude, Monte Carlo simulation is particularly useful in projects with complex and uncertain variables. It helps project managers move beyond single-point estimates and consider a range of possible scenarios. This approach enhances the ability to develop realistic project plans, allocate resources effectively, and manage risks in a more informed manner.
Thank you for watching the video. Please share your feedback in the comments section. If you liked the video and would like to see more on the concepts of project management, request you to please like and subscribe. We'll be back with much more interesting and improvised content soon.